Hello everyone, in this video we are going to solve the chemistry paper 2R from the exam series January 2022. So this is the 2R paper, 2CR, not the normal paper 2, it's just the regional paper of paper 2. So let's get started. Question number 1. So here is question number 1. Question number 1, two substances are needed to cause iron to rust. Name these two substances. So we know that for iron to rust, the two main components are air and water. So you can write air, and with option you can write also oxygen in exchange for air, and water is the other component. So these are the two components that are required for iron to rust or initiates the iron rusting process faster. So this was the answer for part 1A. Moving to part B, the box gives the name of some substances. Use the word from the box to answer these questions. Part 1, give the name of a non-metallic element. So at first, let us first group down each element in this entire box. So calcium is from group 2, which is a metal. Copper is from transition metals. Gold is transition metals. Zinc is transition metals. Methane is CH4, which is a covalently bonded compound, and it is an organic compound, alkane family. And iodine is group 7. So our question part B1 says give the name of a non-metallic element. Non-metallic element basically means non-metals, right? Non-metallic elements basically indicates to non-metals. Right, from this entire box, the only non-metal is iodine, that belongs to group 7. So the answer is iodine. Iodine. Moving to part 2, give the name of a compound. We have already seen that CH4, methane, is the only compound inside the box, so the answer should be methane. Give the name of the metal that is the lowest in the reactivity series. Calcium, copper, gold, zinc are all metals, but calcium belongs to group 2, that is a very highly reactive group. So calcium obviously doesn't belong to the lowest part of the reactivity series. We are left with transition metals. All transition metals are very less reactive, but compared to gold, zinc and copper are still more reactive. So the least reactive element from the reactivity series is gold. So the answer should be gold here. GOLD, gold. With this, our entire question number 1 ends. I hope it was clear enough for you all to understand. Moving to question number 2. Crude oil is a mixture of hydrocarbons. The passage is about the industrial separation of crude oil. Complete the passage by adding the missing word. So we need to add the missing words from each passage. Crude oil is dashed to form vapor. So we know to form vapor, we just need to heat any kind of liquid. So crude oil is heated to form vapor. The vapor is passed through a fractionating column. And the refinery gases are collected at the top of the column because they have low boiling point, right? Because the higher the boiling point and the lower the columns they will be received from. Low boiling points. They're collected at the top of the fractionating column because they have very low boiling points. Part A is done. Part B, bitumen is collected at the bottom of the column. Give one use of bitumen. Bitumen is used in road surfacing or making the roof. You can write either of the 2 points because only 1 mark is given for this question. So we can write road surfacing. One of the hydrocarbons in crude oil is an alkane with the structural formula this. Give the name of this alkane. So in order to name any alkane, I first count down the number of carbons in that alkane. So we have carbon number 1, carbon 2, carbon 3, carbon 4, carbon 5. It has 5 carbon and it belongs to the alkane family. So the ending must be ANE, and 5 carbon means it is a pentane. So the compound is pentane. Calculate the relative molecular mass of this alkane. We already know it has 5 carbon and it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 hydrogens. The AR of carbon is 12 and the AR of hydrogen is 1. So we can write it down as MR of 5 carbon added with 12 hydrogen. So it will be 5 into 12 plus 12 into 1, which is basically 72. So the entire MR of this compound pentane is 72. And with this, our entire question 2C ends. Moving to part D, catalytic cracking is used to convert long chain alkanes into short chain alkanes. Give the name of the catalyst and the temperature used in catalytic cracking. There is no explanation much needed for this type of questions. It's just the theoretical question. The catalyst needed for catalytic cracking is, you can write either alumina or silica, that is aluminum oxide or silicon dioxide. I'm writing alumina. And the temperature is fixed. The temperature should be around in the range of 600 to 700 degrees Celsius. So it is 600 to 700 degrees Celsius. Part E, catalytic cracking also produces alkenes. That means from a long chain of alkenes you can get alkenes as a product. Decane C10H22 can undergo cracking to give C4H10 and two different alkenes. There must be alkenes, the other two products that are unknown, there must be alkenes. Complete the equation for this cracking process. So we have, in the start, we have C10H22 and after cracking it, it produces three products. One of the product is C4H10. So after getting C4H10, we are left with C6H12. And now we need to divide this C6H12 into two alkenes. So if you make C3H6, it is an alkene, and again the leftover thing is C3H6. So these are the two alkenes that we can obtain from the leftover C6H12. I hope this entire question number 2 explanation was clear enough for you all to understand. Moving to the question number 3. A student does titration to find the concentration of solution of dilute sulfuric acid. The student uses these solutions and the apparatus. Dilute sulfuric acid is used. Potassium hydroxide solution of concentration 0.24 mole per dm cube and methyl orange indicator. So these are the diagrams of the instrument the student used. It is conical flask. This is pipette. And this is burette. So the question is part A. The student wants to find the volume of sulfuric acid needed to neutralize 25 centimeter cube of potassium hydroxide solution. So describe the student should do this. So describe how the student should do this titration. Assume all the pieces of apparatus are clean and dry. So these are just theoretical questions of 6 mark. So the entire explanation of this thing goes like, the student first pours 25 centimeter cube of sodium hydroxide into this conical flask first, and then add the methyl orange indicator. And after adding the methyl orange indicator, the student uses burette and starts adding acid drop by drop, and swirl the entire conical flask. After each drop of acid is added to the solution, and the process is continued until the entire solution becomes colorless, sorry, yellow, because the indicator was methyl orange, and the color of methyl orange in neutralized solutions is yellow. So I hope the explanation was clear of this entire part. I'm going to just write down the answer. So the entire answer is the student should use a pipette to transfer exactly 25 centimeter cube of potassium hydroxide solution to the conical flask, the first point. should use a pipette to transfer 25 centimeter cube of potassium hydroxide KOH to the conical flask. And add a few drops of methyl orange to the flask or to the solution. Methyl orange to it. And after that, they should start adding the dilute sulfuric acid to the conical flask using a burette drop by drop. Start adding dilute sulfuric acid to the flask using burette. Drop by drop, and swirl the solution continuously. And swirl the flask. Continue this process until all the solutions turns blue, turns yellow. So from the burette reading, they can actually get the exact amount of volume of acid needed to neutralize the entire 25 centimeter cube of potassium hydroxide, and then need to repeat the entire experiment 5 more times to calculate the average value or obtain the concordant results. So now we need to write from the burette readings. They can get the exact volume of H2SO4 required to neutralize 25 cm cube of potassium hydroxide, and repeat the titration five more times to obtain the concordant result. So this was the entire solution for question number 3A. Moving to 3B. The student needs 15 centimeter cube of dilute sulfuric acid to neutralize 25 centimeter cube of potassium hydroxide. The equation for the reaction is this. Calculate the amount in moles of sodium hydroxide in 25 centimeter cube of potassium hydroxide solution of concentration 0.24 moles per dm cube. So we need to find the number of moles. The number of moles is exactly what we need to find for the potassium hydroxide. The potassium hydroxide has a volume of 25 centimeter cube and a concentration of 0.24 moles per dm cube. So at first we need to convert the volume into decimeter cube. That is, we can write volume equals to 25 divided by 1000. And if you do this calculation, you get a value of 0.025 decimeter cube. 0.025 decimeter cube. So this is the volume of sodium potassium hydroxide in decimeter cube. And now in order to find the number of moles, we are using the formula number of moles. We are using the formula of concentration into volume. So concentration was 0.24 into 0.025, and if you calculate it, you get a value of 0.006 mole. There should be another 0, so 0.006 moles. So part B1 is done. Moving to part B2, calculate the amount in moles of H2SO4 in 15 centimeter cube of the sulfuric acid. So the volume is given, and now we need to find the number of moles of H2SO4. So for this part, the volume really doesn't matter. We are using the entire equation to find the number of moles of sulfuric acid. From the equation, we can see that the mole ratio of potassium hydroxide and sulfuric acid is 2:1. We need to write it down in this entire working. We know the mole ratio of H2SO4 is to potassium hydroxide is 1/2. We can see that from this equation, because 2 moles of potassium hydroxide is reacting with 1 mole of sulfuric acid. So the mole ratio of sulfuric acid to potassium hydroxide is half. So the number of moles of H2SO4 is mole ratio, that is half, into the number of moles of potassium hydroxide, that was 0.006. So the entire number of moles of sulfuric acid is 0.003 moles. So this is 0.003 moles. And now the concentration in mole per dm cube of the sulfuric acid, part 3 tells us to find out this. The concentration in moles per dm cube, right? So exactly in moles per dm cube, we have already given the volume of sulfuric acid in centimeter cube. Now we need to convert the volume of sulfuric acid into decimeter cube, and that would be volume is 15 divided by 1000. So you get a value of 0.0015 dm cube. And now we need to find the concentration. So the equation for concentration would be number of moles by volume. So concentration is number of moles by volume. Number of moles is 0.003 divided by volume is 0.0015, and if you calculate it, you get a value of 0.2. So 0.2 moles per dm cube. So this is 0.2 in the blank. With this, our entire question number 3 ends. I hope it was clear for you all to understand. This was the solution for question number 3. Moving to question number 4. This question is about alcohols. carboxylic acids and their reactions, alcohol carboxylic acid and their reactions. The boxes give information about a carboxylic acid. Complete the boxes by giving the missing information. So this is the structural formula of a carboxylic acid. When you name the carboxylic acid, so it has two carbon, we can see, like carbon 1 and carbon 2, and OOH is a representation of the carboxylic acid group. So 2 carbon means it's ethane, and as it is combined with OOH, which is an carboxylic acid group, so it will be ethanoic acid. So ethanoic acid. Now we already know this question was dealing with carboxylic acid, and there isn't any carboxylic acid with formula CH double bond O. So this is not how the carboxylic acid works. So this must be an empirical formula. So this is an empirical formula. And the displayed entire working of this would be C combined with 3 hydrogens, 1 hydrogen here, and another double bonded oxygen. Sorry, I made a mistake. COH and double bonded oxygen. Right, this is how the entire displayed formula for ethanoic acid looks like. I hope it was clear for you all to understand. Moving to next part. Ethanol can be oxidized to form a carboxylic acid. Give the name of the two reagents used in this reaction. So this is a reaction form that all type of alcohols can be converted into carboxylic acids. The reagents for this are potassium dichromate 6 and dilute sulfuric acid. So these are potassium dichromate 6 and dilute sulfuric acid. And the color change, there will be a color change for this reactions, that is orange to green. Right, so this is a type of reactions that we study in our course. So part 1 is dilute sulfuric acid and potassium dichromate 6. Part 2, which of these color changes occur during the reaction? We know the color changes for this reaction is part B. So part C, alcohols and carboxylic acids can be heated together to form esters. State why it is better to heat the mixture using a water bath rather than using a Bunsen burner flame. So the reactants for this reaction are alcohols and carboxylic acid, and the product is ester. So one of the reactants, that is alcohol, it is flammable. That means it can easily catch fire. So whenever we are heating the entire reactants directly under the flame, the alcohol might catch fire and the entire thing might lead to a great explosion or accident. So that's why it's better to use a water bath than to directly heat the reactants under a Bunsen flame. So the explanation for this is alcohols are flammable that might catch fire. Alcohols are flammable that might catch fire. Moving to part 2, an ester has a structural formula of this. Which of these is the name of these ester? So first we are going to count the number of carbons. So 1, 2, 3, and then there's 4. But the fourth carbon is not directly attached to carbon number 3. It is somewhat attached to the oxygen. So let us first draw the entire diagram. That is CH3 then CH2, and then again C double bonded with oxygen, and then single bonded with CH3. So this is the entire thing. So we have 3 carbon in the longest chain and 1 carbon, 1 methane group on the carbon number 1. So it will be methane, and 1, 2, 3. So methyl propanoid. So option C is the correct answer. Methyl, this is the methyl group CH3, and propanoid is 3 carbons. So 3 carbons. So this is option C is the correct answer for question number 4C2. I hope it was clear enough for you all to understand. Moving to the next questions. Question number 5. This question is about 3 stages in the manufacture of sulfuric acid. In stage 1, sulfur is bound in oxygen to form sulfuric acid. State 1, environmental problem. One environmental problem caused by the release of sulfuric acid into the atmosphere. So one environmental problem is obviously it produces acid rain. So produces acid rain. You can write that produces acid rain, or just acid rain is fine. Part 2, a mass of 6.4 tons of sulfur is burned to produce sulfur dioxide gas. Calculate the maximum volume in decimeter cube of sulfur dioxide gas that can be produced at room temperature pressure. Molar volume of sulfur dioxide gas at RTP is 24 decimeter cube, and 1 ton is equals to 10 to the power 6 gram. Give your answer in standard forms. So we are required to find the volume of gas evolved whenever we are burning 6.4 tons of sulfur to produce sulfur dioxide. So at first we need to transfer the mass from tons to gram, that is using the unitary method. If 1 ton is equal to 10 to the power 6 grams, then we have 6.4 tons of sulfur that have to be burned to produce sulfur dioxide. So it will be 6.4 into 10 to the power 6 gram. So the mass is 6.4 into 10 to the power 6 gram. And in order to find the volume, that is moles, and now we need to find the MR. Sorry, not MR exactly. Right, yeah, sulfur is always S2. Let me look at the equation. No, it's single S. So now we need to find the number of moles. Right, now if we using the equation, number of moles is equal to given mass by AR, that is 6.4 into 10 to the power 6 divided by 32. If you calculate it, you get a value of 2 into 10 to the power 5. So 2 into 10 to the power 5 moles. This is number of moles. And to find the volume of gas, volume of sulfur dioxide produced in decimeter cube, you need to divide this. So multiply this with molar volume. So volume is number of moles with molar volume, that is 2 into 10 to the power 5 into 24 decimeter cube. And if you calculate it, you get a value of 4.8 into 10 to the power 6 dm cube. So this is 4.8 into 10 to the power 6. Remember to keep your answer in standard form as the question asked you to do so. So part B2 is done. Moving to part A2 is done. Moving to part B. In stage 2, the sulfur dioxide is reacted with oxygen to form sulfur trioxide gas. The yield of sulfur trioxide is approximately 98%. A catalyst is used in this reaction. Explain how a catalyst reactions increases the rate of the reaction. So this is a typical written theoretical answer, that a catalyst always provides an alternate path for the reaction and carries out the reaction with a lower activation energy without the catalyst being chemically changed itself. So here the entire definition would be: it provides an alternate path for the reaction to occur at lower activation energy. It's not okay to write activation energy like this in written answer. So lower activation energy So these are the two mark scheme points for this question. Part B1 is done. Moving to part B3, the temperature is kept constant. Give a reason why increasing the pressure would increase the yield of the sulfur trioxide. So this is the right hand side of the equation and it is the left hand side of the equation. We can see there are 2 moles on the right hand side and there are 3 moles on the left hand side of the equation. So whenever we are increasing the pressure, the equilibrium of this equation will shift to the side where there are fewer moles. So we can see that right hand side has fewer moles. So the equilibrium will shift to the right hand side, producing more of the product, that is sulfur trioxide gas. So increasing the pressure increases the yield of sulfur trioxide because there are fewer moles on the right hand side of the equation. On the right hand side, so equilibrium shifts to the right. Equilibrium shifts to the right. Part 2 is done. Moving to part 3, suggest why it is not necessary to increase the pressure in stage 2. Because it is not necessary to increase the pressure in stage 2 because the yield is already 98%, which is more than enough. So increasing the pressure would mean increasing the cost and the entire result won't be that much of beneficial. So that's why increasing the pressure is not that much cost effective as the yield is already approximately 98%. So we can write that as yield is approximately 98%, so it is not necessary to increase the pressure. To increase the pressure. Part C, in stage 3, the sulfur trioxide is reacted with concentrated sulfuric acid to form a liquid called oleum H2S2O7. The oleum is then added to water to form concentrated sulfuric acid. Complete the reaction. So we've already stated, the entire thing already states that sulfur trioxide is added to concentrated sulfuric acid to form oleum. So the first equation will be sulfur trioxide, which is SO3, reacts with H2SO4 to form oleum, and then the oleum is added to water. So oleum is added to water. This is oleum and this is added to water to form concentrated sulfuric acid, so which is H2SO4. The first equation is naturally balanced, but the second equation is not balanced. So in order to balance it, we need to use, there are 4 H2, there are 4 hydrogens on the left hand side, so we have to balance it by using 2, and this balances the sulfur also and all the oxygens also, so everything is balanced now. With this, our entire question number 5C ends. Moving to 5D. Sulfuric acid reacts with ammonia to form ammonium sulfate. Calculate the percentage by mass of nitrogen in ammonium sulfate. So the MR of ammonium sulfate is 132 and there are 2 nitrogens used. So 2 nitrogen used means the mass of nitrogen used is mass of N2 is basically 2 into 14, that is 28. So percentage by mass of nitrogen in NH4 2SO4 is basically 28 over 132 into 100%, and if you calculate it, you get a value of 21.21%. So with this, our question part D ends. Question 6. A teacher prepares that salt table, the insoluble salt lead to bromide PbBr2 by mixing solutions of lead to nitrate and sodium bromide. Describe what the teacher should do next to obtain a pure dry sample of lead to bromide. So the teacher has already prepared lead to bromide, but it is not exactly in dry sample solutions. So in order to create the dry sample solutions, the teacher must filter the solution first to get the lead to bromide away from the sodium nitrate, because entire equation it looks like we are starting with lead to bromide reacting with sodium bromide, and this produces the lead to we started with lead to nitrate. We started with lead to nitrate and reacted that with sodium bromide, and this produces lead to bromide and sodium nitrate. So to get pure dry samples of lead to bromide, we need to filter the solution of lead to bromide and sodium nitrate. So we have to first write filter the solution. Filter the solution to get the lead to bromide as residue. The residue is washed with distilled water to remove impurities, and kept in a warm room to dry them out. Right, so this was the entire work solution for question 6a. I hope it was clear enough for you all to understand. Part B, the teacher then sets up a circuit into a film cupboard using the pure dry sample of lead to bromide. Explain why the lamp does not light when lead to bromide is solid. We know whenever the ionic compounds are solid, the ions are not free to move. And if the negatively charged ions are not free to move, they won't carry electricity to conduct the entire bulb. So we have to write lead to bromide does not conduct electricity in solid state because the ions are fixed. So lead to bromide cannot conduct electricity in solid state. As the ions are not free to move. Part C, the teacher heats the lead to bromide. When the lead to bromide is molten, the lamp lights and bromide forms at the positive ion. Still, what observation would be made at the positive electrode? So as the question already states that bromine is forming at the positive electrode. Bromine is a gas, brown vapor. So obviously the observations would be a formation of brown gas or brown vapor. So we can write formation of brown vapor is seen. So with this, part C1 ends. Explain how bromide ions in the molten lead to bromide become bromine molecules at the positive electrode. At first, here the bromide ion is a negatively charged ion with a charge of -2, which indicates it has 2 electrons extra. So at first, the entire point would be bromide ion is a negatively charged electrode. Negatively charged ion which is attracted to the positive electrode electrode where the bromide ion loses electrons to become bromine atom. And now we can write the half equations at the positive electrode, that is Pr minus becomes Br, and it gives out 1 electron, but Br never happens a single atom, it always is a diatomic molecule. So in order to balance it, we have to balance the entire equation. So this is what the entire explanation for part 3 looks like. Moving to part D, write the half equation for the reaction that occurs at the negative electrode. Include state symbols in your equation. So the state symbols for this would be obviously lead 2 is used, so it has a charge of +2. It gains 2 electrons with negative charge and produces lead. And as state symbols are required, lead to bromide is liquid, so liquid electrons doesn't have any state symbols, and lead is solid lead that is collected at the bottom of the negative electrode, so this is S. With this, our question number 6 ends. Moving to question number 7, the last question of this paper. The reaction between hydrogen and chlorine is exothermic. This is the equation for the reaction. State the meaning of the term exothermic. We know reactions that give out thermal energy are known as exothermic reactions. So we have to write reactions that give out thermal energy. So this was the explanation for A. Part B says the table shows the bond of energies for the HH and HCl bonds. Use the equation and the information from the table to calculate the bond energy of the Cl bond. So we already know the enthalpy change for this reaction is -184 kilojoules. So first we have to calculate the energy required for energy required for the reactants and energy required for the products. Bond energy for reactants are basically H2 and Cl2. H2 is 436, but Cl2 is not known, so let me write it as Y. And bond energy for products is HCl, but this is twice HCl and this is 1 HCl, so it will be 2 into 431, which is basically 862. Now the entire equation for enthalpy change was delta H is equals to products minus reactants. Delta H is minus 184. Products is 436 plus Y, and reactant is minus 836. So if you make Y the subject of this equation, it would look like 862 it was. 862 minus 436 minus 184, and if you calculate it, you get a value for the Y, which is 242 kilojoules per mole. So the entire bond energy for the Cl-Cl bond is 242 kilojoules per mole. So we can write 242 kilojoules per mole. So with this, our 7b ends. Moving to 7c, explain why this reaction is exothermic. Refer to bond breaking and bond making in your answer. So any reaction is stated to be exothermic whenever the bond making is greater than bond breaking. So let us first write, in order to form HCl, it first needs to break the existing bonds between hydrogen and chlorine, which needs energy, and then it needs to make bonds between the hydrogen and chlorine to form HCl, which releases energy. Now the reaction is exothermic because the energy given out is greater than energy needed. So this reaction is exothermic because energy given out is greater than energy needed. So with this, our part C ends. Part D, complete the reaction profile diagram to show the position of the products, the enthalpy change, and the activation energy for the reactions. So as you already know that this is an exothermic reaction, that means reactants must be at a lower enthalpy than the products. So the reactants must be at this level approximately, and the products must be at this level. So products must be at this level, and the product was 2HCl. Let me write it down to a little left. Right, 2HCl. We need to obviously show the enthalpy change and activation energy on this diagram. So enthalpy change is this difference in energy. So we can write enthalpy change was negative 184 kilojoules per mole, and the activation energy was like this, and from this point to this point is the activation energy, EA. So this is how the entire reaction profile diagram would look for this reaction, and this is how the entire paper for chemistry January 2022 paper 2R ends. I hope my explanations was clear enough for you all to understand, and if you like this video, give it a thumbs up and share it with your friends. Thank you for watching.